quick revision on this one. This is exactly like we were doing yesterday. Was that? Well, this is especially for you then. All right, so we're talking about a right-angled triangle. We know it's a right-angled triangle because it's got a box drawn in the corner. And because we know that we're talking about a combination of sides and angles, this is a question about trigonometry. This is not a question about Pythagoras. So, the first thing we need to do is label all the bits of information that we have. The angle that we're told is theta, and that's this little squiggly O with the line through it. If we go from theta through the middle of the triangle, we end up over here where our x is. That's what we call the opposite. If we go from the right angle, this one over here where the 18 is, that's called our hypotenuse, so we chuck an H on there. And the third side of the triangle is A for adjacent. Good. All right. So looking at the information we have, we know the angle, so we've got a theta. We know the hypotenuse, so that's known. We want to find out the opposite.
Adjacent can get lost.
Yeah, adjacent, we just could not care less about adjacent. So of the three trig ratios that we know, which one uses the angle, opposite, and hypotenuse? Sine, good. First thing, sine theta equals opposite over hypotenuse. So the whole point of doing that labelling is just to make sure, just to find out that we're using sine. Write down that equation. Okay, now replace all those variables with the things we know. Sine 31 equals, our opposite side is x, and the hypotenuse is 18. Yep, you got it. Well, you're close to getting it. We want x by itself, that's true. So we are going to times this side by 18. We're also going to times this side by 18. That and that cancel out. So if you pick up your calculator, remember, make sure your calculator is in degrees mode. Deg mode. If your calculator's in degrees mode, 18 times sine 31 will tell you the length of x. Has anyone got a negative answer? Okay, that's cool. I was just experimenting, and you got what you should get. I deliberately typed it in a little bit backwards and got negative 0.309. All right, 9.27068538. You're right, 9.27 is good for that. What's the units? Meters, accurate to 2 decimal places. Good. X is 9.27. Now, this one here, that's exactly what we've been doing for the last 2 days. We're not spending a third day doing that. We're going a step further. So the heading here was solving for the denominator or the angle. Every single time we've done trig so far, what we wanted to find is actually the numerator of the fraction. So, next trick, here we go. Take a moment. Michael, copy this down, please. So go ahead and label, well, first get that sketch sorted out, label all the bits that you know. .42 is my theta. Yeah, good. So we've got an opposite over here, we've got an adjacent here. My hypotenuse is there. Theta I have. Opposite I have. Adjacent I want to find out, don't care about it. So Don't care about hypotenuse, so which ratio are we going to use? 10. Yeah, thanks boys. Let's go. Tan theta equals opposite over adjacent. All right, replace theta, O and A with actual numbers. Tan 42 equals 9 over x. All right, can you see how this is different from everyone you've done so far? Okay, now we could do a bunch of algebra and go through what we're going to do here, but instead I'm just going to give you the heads up straight away. Easiest way to rearrange this to get x by itself is take everything that's over here, and switch them. And all the rules of algebra says we're allowed to do that. So your next line of working out will look like x equals 9 divided by tan 42. Yep.
Nine point nine nine.
9.
But if I round that would be 10.
Yeah, you're right. It doesn't matter which way you look at it. It's going to be 10.0, we'll call that 1 decimal place, centimetres. All right, we're going to be happy with that? That's cool. That's cool. You get it. The only way you'll get through that, Michael, is to practice a few of them. You could hit up my YouTube channel and learn all about it. Does that sound exciting? Subtle plug. All right, so everything we've done so far, we've had the unknown as the numerator, and we've just been multiplying the denominator by both sides. This time, the denominator is the unknown, and we just do a switcheroo, and that's okay. That's how you find when the unknown is on the bottom. The last thing we'll do here is a situation where we've actually been given a right triangle with 2 known measurements, but we don't know the angle. So we're going to use trig ratios to calculate the angle here. So let's go ahead, let's label what we know. We got theta, obviously. Opposite up there, adjacent over here, hypotenuse over here. Do not care about opposite whatsoever. So which ratio uses A and H? Sine, cos, or tan? Cos, that's right. So let's write down cos theta equals A over H. All right, we're going to put in all the information that we know. Working down the page, keeping your equal signs lined up. Cos theta equals 14 over 19. Now, this is where it gets a bit tricky. One thing we could do is we could pick up our calculator and find out what 14 divided by 19 is, but we're not going to do that. We don't need to do that. What we're going to do instead is we're going to try and find out how our calculator can work backwards for us and tell us what number we could put in place of that theta symbol. So what number could we actually put here to make this statement true? And our calculator can do that for us. So we're just going to show that we know what's going on here. We're going to write theta equals, we take our ratio, we're using cos this time, so we write cos, and we put a little to the power of -1. (14 over 19). So we haven't really done anything tricky. We're just showing that we're about to go to our calculator and we're going to ask it to solve for the angle for us. Yeah, shift cos is what's going to do it for you. It's up to you whether you enter 14 over 19 in your calculator as a fraction, or you could just have those brackets and put 14 divided by 19. That works.
42.5.
Yeah. Now, 42.53, seriously, we're talking about degrees here. How many decimal points do you think we really need?
2, 1.
Let's go for 1. There's no point in going for more than 1, because we can't measure more than 1. Yeah, okay, so yeah, we'll call it 42.5. 42.5 degrees, 1 dp. All right, I'm going to hit stop on this now.